Welcome DKP Sogong aboard. Your learning journey starts now. Ever felt like some math problems are just too good to be true? Like they're hiding a secret handshake between geometry and numbers? That's the vibe with the Hodge conjecture. For ages, we've been scratching our heads. Why should these specific rational classes in cohomology always come from algebraic cycles? Well, buckle up because there's a new player in town and it's got a mouthful of a name, RBACE. And guess what? It might just have cracked the code. So what is this magical R-base thing? Think of it as a detective toolkit for mathematical objects. Instead of just looking at the shadow, the cohomology class insists on examining the object itself. It starts with a finite projective semantic object, basically, a well-documented mathematical entity. This object has p-pairs of balanced poles. Think of them as perfectly matched gears driving the geometry. The crucial bit, principle R6. It says if you have a rational provenance and these conjugate poles are balanced, then bam! An algebraic cycle must be lurking there, ready to be exposed. It's like finding a hidden message in plain sight once you know how to look. The formula NF sub p alpha equals the sum of q sub I times z sub I. That's just a fancy way of saying we find the algebraic cycles z sub I with rational coefficients q sub I that make up our original Hodge class alpha. Simple, right? Almost. Okay, let's walk through the proof without getting lost in the weeds. Imagine you have your rational Hodge class alpha. Step 1, R-base says, show me your papers. It demands a finite projective provenance certificate. Step 2, check those p-conjugate poles are indeed balanced. Now, the fun part, find the biggest, most stubborn unresolved relation within this object. This is your maximal source. Step 4, here comes the magic. R-base applies its exposure operator, delta p, which finds an algebraic cycle z that perfectly matches this source. We subtract its contribution, q cell of z, from alpha. This consumes the source, leaving a strictly smaller residue. Repeat. Like peeling an onion, layer by layer, until all that's left is a nice tidy sum of algebraic cycles, the base normal form, NFP of alpha. The final step, just check that this new combination, when projected back into cohomology, gives us our original Hodge class. Voila! The classical equation holds. It's not searching for cycles, it's systematically exposing them based on inherent properties. Now, why should you care about this proof? Because it's different. It's bold, sure, but it's also honest. It doesn't just restate the Hodge conjecture, it builds a whole new system, R-base, where the conjecture becomes a theorem. The definitions are clean. A rational Hodge object is defined by its rational provenance and pole signature, while an algebraic base is defined by its incidence relations. They're separate. The proof happens at R6, showing how a balanced source forces an algebraic exposure. This internal logic is rock solid. But here's the catch, the external frontier. For the Clay Institute to award the $1 million, someone needs to prove that this RBA's principle, this R6, actually works for every single classical Hodge object out there. It shifts the difficulty from finding cycles to proving the fundamental principle of their exposure. It's a game changer, moving the focus from cohomology's shadow play to the real thing, semantic provenance. So, where does this leave us? The internal proof within the R-base system is complete. We've built the machine, run the demo, and it works beautifully for the cases we test. But the grand prize, the universal validation across all classical Hodge scenarios, that's still the open challenge. The real legacy here isn't just potentially solving a millennium problem, though that's huge. It's about changing how we think about mathematical proof itself, focusing on the object's inherent structure and provenance, not just its shadow in a chosen formalism. The next big question is whether this principle of rational balance forcing algebraic exposure holds universally. Stay tuned, the math world just got a lot more interesting.